In this video we're going to learn about density. And density, as you all know, determines whether or not something sinks or floats in something else. And what it has to do with is the amount of stuff or quantity of matter that you have, which is defined as mass, divided by the volume that it occupies. So comparing these two layers, this top oil layer has a lower density than the water, which has food coloring in it, layer that is below, and that's why it floats over the water. So mass is pretty straightforward with how we determine it. It's really, in a lab, what we'll do is we'll record the mass on an electronic balance. Typically that's what we'll do. Volume, however, is a little bit more complicated to calculate sometimes. If you have a regular shaped object like a cylinder or a sphere or a box, there are equations that we can use to calculate the volume. Sometimes, if you have an irregularly shaped object, we need to use water displacement in order to determine the volume. So if it's a cylinder, pi r squared h. If it's a sphere, 4/3 pi r cubed. Box, length times width times height. And if we're using water displacement, all you have to do is look at the final volume once you put the object in and compare that to the initial volume that you had before you put the object in. So we could also rearrange this equation to isolate mass, and that would give us the density times the volume. Or you could isolate volume, if you know the mass and density, that the volume is equal to mass over the density. So just looking at this one, I just want to show that if you do a relationship between mass and volume, the slope that you would get from that line would be the density, because looking at this equation, that would be the coefficient over volume, in front of volume. Now, just wanted to go over a couple sample calculations that we could do involving density. First type, which is a little bit straightforward, I could ask you, give you a mass and give you dimensions of a shape and ask you to determine the density. So in this one, I asked you to calculate the density of a block. I give you a mass of 12.86 grams, and then length, width, and height dimensions of 2.54 centimeters, 3.28, and 4.68 centimeters. So all you have to do is put the mass over the volume, and the volume we would calculate, since it's a block, is length times width times height, and we would get ourselves an answer of 0.330 grams per cubic centimeter. Now, in further units, we're going to do calculations with density that involve conversions among these to get us to our answer, but for now, this is good. Another type of calculation, I could ask you to go one step further and ask you to calculate some component of the volume using the mass and density. So in this one, I have a 5-gram cylinder with a density of 2 grams per cubic centimeter. If the cylinder length is 1.20 centimeters, what's the radius? So in this one, we have the mass, we have the density, and we rearrange the equation to show volume is equal to the mass divided by the density. We solve for that and we get our volume. Then what we'll do is we'll do a second layer of thought and show, well, if I know the volume and I know the length of the cylinder, I would use this equation to find the radius. So we have pi r squared times the height. Isolating for the radius squared, we would have the volume divided by the height and pi. And that gets us a value with our numbers that we have of 0.663 square centimeters. And then since that's a squared amount and we're looking for the radius, we would just have to take the square root of that, and we would get 0.814 centimeters. So density is a relationship between mass and volume, and we can manipulate that to find a whole bunch of things.